Let's go. As usual, waiting for Twitch to catch up. And any second now. There we go. I should be live. Hello, everyone. Welcome to a short and chill stream. No camera this evening. This is not a planned stream. I didn't plan to stream today at all. But I have a few hours this evening during which I can make progress on the project. And as usual, I don't want to write any code for it outside of the stream. The goal is for the entirety of it to be done live. So today, let's do some slightly less important cleanup work. What I want to do this evening is to redo the pretty printing, which is basically like exporting a printed version of the AST, both before and after validating it, both for debugging purposes and also to write tests. I have some old tests that are currently broken by the fact that with the big refactor we've been doing, there isn't any way to currently pretty print an AST. So this is what we're going to be doing this evening. I don't know how far we can go. I also have a plan of like in terms of debugging of maybe making an HTML export of the AST with annotations like tooltips and other things like this to visualize in a more in an easier to visualize way than just like printing stuff to the console. Basically, we will see how much progress we make. First, I want to clean some of the stuff that we have left as comments in the new AST file. And the other thing I want to do is to remove all of that stuff. There we go. And now what I want to do is I want to migrate the old pretty code. The big difference is in the old version of it, it was all made as type classes, as in there's this pretty type class that is a part of the library I'm using for pretty printing, and it defines a method pretty, which is just how do I prettify this object? How do I like put it in the pretty printer? I would like to change this because the downside with this approach is twofold. First, it ties one specific implementation to a given type. Like there is only one way to prettify a given type. And two, if I define my pretty instances in a dedicated file like this, then uh, they are orphan instances. They are not tied to the definition of the type, nor to where the type class is defined, which is not the end of the world, but that's two reasons not to do it this way. So I think I'll try to get this old code, but I'm going to rewrite it to not be type classes and instead to be functions. Now the question is, where do I put this? I have this export folder that I had like planned to be like all of the code that exports state from the compiler in one way or another, like maybe printing the control flow graph of a particular function into an actual dot graph that can be visualized, something like this. And I think we will want to just make the pretty printing as part of this. I suppose we could just make it like a dedicated folder, and we could, I suppose, use parsed and resolved. Or I guess we could just do AST. Will there be other things that we need to pretty print? That is the question that I do not know. I suppose there might be, so maybe just doing AST like this might be the best solution. Wait, what's the go? Which means I'll get that and I'll copy that old code, not the lenses, just the pretty print. There we go. Into here. I'm gonna copy, I don't know if I have access to it still. Just remove this old file. I don't think I still have the list of all the imports we used to have, but we will need for sure at the very least. As usual, I might want to avoid importing common and just have like passed and validated as my modules. And we will need the module, the library I'm using is just called Pretty Printer, if I remember correctly. Yeah, that's the one. I'm tempted actually to maybe make it... Huh. I was going to say, do I want to split this into two files? One for the passed version of the AST, one for the validated version of the AST. On one hand, there's going to be a lot of code in common between the two of them. On the other, I will want to define things such as annotations that are going to be different per thing. So maybe instead, we create a subfolder and we define the pretty printing for each file. This file at the root at top level will just re-export some of the basic functions. If we do that, then this one I'm going to actually write into pretty printing AST passed. Which means here I can define things for just the passed AST. And anything that is common, I'll just put in common or something like this. Now, the thing I want to change compared to the old version, given that I have this idea of the HTML export in mind with like color syntax, like syntax highlighting and so on, will be that we will want to annotate things with like their semantic meaning. I guess for the past version of the AST, we do not have like type names or anything like this. So our annotations are going to be limited to like is something a int literal, is something a character literal, or maybe just literal, like booleans or something. No, I think we can do it this way. Character literal, string literal, keyword. And is there anything else we want to annotate at that stage? We could annotate punctuation to like do syntax highlighting for parentheses and stuff like this, but I don't think we really need that. I think if we already, and I suppose, however, no, path annotation, anything that is a name, whether it's a variable or something like this, will be annotated as being passed as a path. Okay, so what we will need out of this, our interface out of this, is going to be it's going to be something along those lines. I think I have, there we go. I already have something from the old code that we can use. Except this is saying we take anything that can be prettified, since again the goal here is to remove this. This will take... Do I want to print an entire module or do I want to expose? Or maybe I could use the same kind of like approach to pretty like this with a class, But instead, I use my own that I define in this file, which removes the problem of an orphan instance, and then I have an interface per module, and I no longer have the problem of I'm tying the thing to only one implementation. I don't know. I don't know. No, I think we're gonna do this for an entire module. So PrettyPrint will render an entire module. This will be not render strict. Actually, it might actually be. And layout smart, I think, is even better. If I remember correctly, how this thing works. I think layout smart is more look ahead than layout pretty. There we go. Okay. And then this will delegate to pretty module, which will be our hidden implementation detail. Oops. But the thing is, the way the library is set up, every document, which is the like basic type of a thing that we are prettifying, has an annotation type. Here, rather than it being an arbitrary annotation type, which is sorry, I hadn't seen your message. Yeah, no camera today. It's a chill stream. I wasn't planning to stream in the first place, but I have a few hours where I can make some progress. And since I never want to work on anything on this project outside of the stream, let's just make a chill stream without the camera and work on something that's not urgent. So I'm working on the pretty printing of the AST, which is going to be used for debug purposes and for fixing some old tests that rely on it that are now broken with the refactor. And I have a secret plan. Not so secret, I suppose. I have a secondary goal that I don't know if I'm going to be able to achieve this evening, which is to use this pretty printing library that I'm depending on to not just do text rendering, which prints a source code and that's gonna print the source code like back into something that could be passed. I also am tempted to do HTML rendering to try to visualize something, basically, like visualize a piece of code in a like in the browser, which would be useful for debugging purposes because we could make stuff like having annotations, tooltips, and other things like this. So rather than reading the console of like what is this thing that we have passed, maybe making something that exports an HTML page that I can just load and it shows me the code with annotations could be very nice for debugging purposes. So that is what I'm doing this evening. So how do we make a module pretty? This is going to be a function that will take a module and make it into and then return one of those documents that are pretty library handles. And I think this is going to be kept exactly the same. Again, I don't want to keep the old approach of having type classes because one, those would be orphan instances. Two, the instances have to work for any kind of annotation, while I want to use more specific annotations. And third, I want to be able to like not tie a particular type to one specific implementation because I will want to have different ones based on what kind of AST I am pretty printing. So changing this to being functions instead of instances. So I think this, however, still holds. This is going to be separated vertically, a bunch of imports, and then a bunch of definitions. The location information will just be ignored. I don't think I need to keep that. And I'm also very tempted to do a thing where I don't give the type of the functions and I set a flag at GHT to not warn me about it, just because it's going to be a lot of all of those functions will basically have the exact same type, which is take the thing here as input, return a document as output, and that feels a tiny bit redundant. Do I want to keep this use of hsep is something I'm not sure. I'll have a quick look at hsep versus some of the others. hsep does not introduce line breaks on its own, even when the page is too narrow. So maybe that's the wrong one. Maybe we want to do instead fillsep that will introduce line breaks whenever that's required. And otherwise, if I remember correctly, this is just separating things by spaces if there's room. Yes, it's x soft line y, and soft line is behaves like space if the resulting output fits the page, otherwise like line. Yep, that feels correct. Okay. Hcat here will be correct, however. What is the name in the qualified there? Is that an identifier? I don't remember. It's been too long. This would be in past, I believe. That is an identifier. Okay. That is the downside of no longer using the type classes, is I have to, every time there was a call to pretty before, I have to be explicit like, no, this is a pretty identifier. However, here we're already going to see a few things. I'm going to introduce pretty keyword. And pretty keyword will be, let me have a look at how annotations work. There we go. So just annotate and the document. Pretty keyword is going to be annotating with the keyword annotation whatever is given to me as an argument. So it's going to be a pretty keyword here, because use is a keyword. That's a path. So that's going to be, maybe I don't need to do this. I can just say annotate keyword. That's enough. This is annotate with a path. Those are just identifiers. So none of those require anything. However, this is a keyword. There we go. Now, how do we like prettify a definition? It's going to be the same thing again. Except again, since we no longer have this generic pretty thing, we're going to have to say pretty type alias, pretty enum, pretty struct, pretty const, and pretty function. A pretty type alias info will be I think we want to do fill sep there again. Although maybe we want to use the hang function to indicate that if something doesn't fit on the line, unless we decide we don't care about line length at all, and we just hsep absolutely everything like it was, which maybe is easier than trying to do have something working is a lot easier than trying to do something that's pretty and like does hanging and indenting cleanly. Maybe we can just do that to start with. Maybe I'll go back to how it was for simplicity. So this becomes annotate keyword doesn't exist, but this is a keyword annotation. Oh, I still have annotate keyword here that no longer exists. I need to fix that. And that's just a name, so that's going to be pretty of an identifier. That's a very peculiar... I might just do this for now. And this is going to be a pretty path, I think. Oh, although I have to be careful here. Because an import path is different. An import path is just a non-empty identifier. Okay. And this, however, is going to be what is called a path info at this stage, I think. Okay, type alias is, yeah, it is a path info. So I think just to avoid getting them mixed up, I'm going to use here pretty path info. Okay. We can continue this. This is pretty enum of an enum info. We keep the hsep thing. We're not changing that. That's annotate with the keyword annotation. Enum. Pretty identifier the enum name, and those are just identifiers, and we don't need to annotate them with anything. So they're just that. Next, what do we have? Annotate keyword annotation. Again, we have literal, keyword, and path. I guess I could, instead of using annotate path, I was going to say I could just make it so that annotate pretty path and pretty path info actually use the annotate for me. Wait. Yeah, this is incorrect. And I think this is different. So maybe I'm just going to use pretty path here. And I will probably then have pretty path do the annotation. That way I don't have to do it at every call site. That makes more sense, I think. Okay. We can continue. So a struct has a identifier as the struct name. Pretty params are going to remain. I'm just going to remove this. And then I might choose instead to do a pretty block here. Oh, wait, no, this is not a block. This is just... Okay, so that may be correct, except I might want to do a space here. Do I want to use a new line there, actually? There is a thing this pretty printing library that I'm using has a thing called line, if I remember correctly. No, sorry, list and tuple, actually, tuple, there we go, that uses the same kind of layout that Haskell uses. Which is, yeah, okay. Hmm. Maybe we don't need to do that. We can do it manually instead. Yeah, I think we might be able to do it manually. This is going to be... However, that means we have to change a few things. So this ends up with this opening bracket, and that's all separated by spaces. Then we have hard line, and then we have a separated by vertical lines, something that is something along those lines, a list of things which are on one line, a comma, the name of the field, and then the type, which is going to be pretty identifier. And that's a type expression, but in the context of our past version of the AST, that should be just a path info, I believe. Again, so we can reuse the function there again. Because that is, yeah, a path info there again. So that is a pretty path info. And at the end, hardline again, which I guess I can rewrite this as being, this is a VSEP, so we separate it by a line. The first thing is this horizontal line. Then we have this set of things separated by vertical lines. And then we have the closing thing. However, no, this might not... I might want... Oh, hello. We might want to do something slightly different here. I think I want to like use the either hang or indent. And which one do we want? I think hang is the one we want. Relative to the start of the first line, yeah, I think this would be correct. So basically, every time there is a new line, I can do it on just... Okay, so this is an hang 2, I think. That's a hang 2 of this. So anything that is beyond the first line will be with an indentation of 2, which I think is what we want. Okay, so now we have a better representation of struct with new line for all of the fields. With which is a formatting which is closer to the Haskell one than the Rust one, but I think I'm okay with that. Then what do we have? Pretty const. That's a keyword. And then pretty identifier. Oh, here I don't need the spaces because HSEP will put some spaces. Here I might need the space, however. Oh, this could be a thing where, like, here I want to fit the enum on one line if I can, and otherwise, if I cannot. So this would be, if I were to do that, I need to do a hang 2 there again. Well, again, I probably don't care about that. I'm just gonna keep it this way. I don't really care about having the pretty printed files fit within 80 characters or anything like this. It's perfectly fine for them to be bigger, because the main goal of this is debugging and, well, testing, and the second is debugging. So I don't need it to look as pretty as the name pretty printer suggests. So const, the name, this is a path info there again, equals, and then that is a pretty expression of what is within the const expression, followed by a semicolon. Finally, functions. Oh, finally. It's the bulk of it, but you know what I mean. That's also, again, a keyword. That's an identifier. Pretty params are a thing we're going to have to define that we haven't defined yet. Enclosed and separated by spaces is going to be the argument. Here I'm going to use an hcat to control where spaces happen, which is here. That's pretty path info there again. Okay, that's still correct. If we have a function return, we are doing a fold map, otherwise we don't do anything. And then pretty block. Hello, how are you? So pretty block is going to be the same. That seems correct. Okay, I'm going to keep this one like this. Let's see. Next we have, so that's pretty function. Next we have pretty statement, which is going to be this. I think I'll want to introduce one pretty function per thing, just so that this kind of case switch is consistent. All of the cases have the same shape. So this would be a pretty return of rs, which I'll define right after here. Yeah, this might be overkill. There might not be a need for this. I'm just gonna do that instead. And this is gonna be a pretty expression. Okay. I am tempted. Well, this case, yeah, okay. This case, I might just keep continuing and break like this. There's not really a point in introducing. My compiler is not AOC ready yet. I was hoping when I started the project back in March that we would be at a point where I could try to do at least day one of Advent of Code in Piètre by generating the code. We're not there yet. I will, however, I still have my old and very basic, very shitty compiler for Brainfuck that still exists. So I will definitely be doing the same thing I do every year, which is to generate some amount of Brainfuck for the first few days of the Advent of Code, because that's fun. But it's definitely not the same level of like actual compiler from like actual language with the parse and everything. It's much more like let's use snippets in brainfuck code, which still is easier than actually writing brainfuck directly. But yeah, no, we're not at the point where I can use this compiler for the Advent of Code just yet. Next year. For this evening, again, I'm just rewriting the old pretty printing code because that's useful for the tests. It's since this no longer works, the tests are broken. And I might go a bit further and try to also make some debugging views to make checking the output of the analysis phase a bit easier than reading just the output of the show class in the terminal. Those would be annotated with a keyword annotation because those are keywords. Return is the same, but it's already done. Now what do we have? For if we have, so that's again, I used to have all of those type classes for pretty, and I don't want to do that anymore, so I'm rewriting those as functions. This is also an annotated as a keyword. That's a pretty expression again, which I don't know why I've written it this way. This is just located of the if expression. Pretty block of the body, that's correct. And then if there is, and those are both annotate with a keyword annotation. And then this remains a pretty if or a pretty block, depending on what kind of else we have. Okay. I should probably... Oh no, I don't have to handle else. That's already handled here. So we're directly moving on to 4. Annotate keyword. I'm just going to copy and paste. The variable name is an identifier. That is an expression there, which is just the located expression of the for range expression, because location information is not required for this. And then we pretty print the block of the body. A while is going to be very similar. There we go. And again, this is just an expression, which is the located expression within this with location thing. And we're getting close to expressions. Now we have the let, which is a keyword. A name, potentially a type, which is a path info, an equal sign, and then an expression, which is again just the located thing of this. Those within stuff is no longer required. And we have made it to expressions. So an expression is going to be, do I want to keep this like very complicated indenting with all of the arrows? Maybe not. So that's just pretty of a path info, that hasn't changed. I think parents is correct. Go is just, I'm going to keep go, but go is pretty expression. Actually, I'm going to do this. Not that it makes a difference, but just because that way I think it's a bit more explicit what's happening. Go is this function that does the recursion. And it is get the located thing and then do a case on the result. I probably don't want to do this. I'm gonna there we go. This just needs to be there we go. That's a pretty path info. For a cast expression, this is parentheses around the recursive case, the keyword as. And then that's a type, so that's just a path info. Yeah, that's all the same. And that's a pretty identifier. Nope, that's a no, that's an identifier. That's correct. Pretty path. Oh, in fact, I can probably rename pretty path info into pretty path because there's not going to be any conflict, and that's shorter. A call expression is going to be pretty path of the name of the function and then separated by commas the expressions of the arguments. No need for functions for parentheses around this. Array expression is going to be yeah, list is a Haskell one, that's fine. I don't have arrays anyway, so that's fine for now. Index expression. Do I ever need to put parentheses around? I suppose technically I could pre-print something that is not valid code. So for instance, someone could do 3 plus 4 and then use an index expression on that. So since I am pre-printing the past version that I have no guarantees correct, I think I need to put parentheses around the thing to be able to be consistent with what was given to me as input. Okay. This one I might introduce an alias just because it's too big to fit on one line, I think. So this is, it takes as an argument the name of the type and the fields of the struct. Okay. So this is going to be pretty path of this, followed by... There again, there's the question of, do I want to indent this or not? And I think in this case, I will not bother. And here, I'm going to rewrite this as being instead a... so maybe here I don't need the hsep, and I can do it as this. And here, this list of fields is for each of the tuple name value in the thing. Pure hsep of pretty identifier the name. Now in this case, I probably want to hcat actually. I guess I can rewrite it as a one-liner. And this is pretty identifier of the name, and no space this operator, space go of the value. Okay. That's strict expression, Boolean, literal, then true, else false. Those are keywords. So this is going to be an annotate keyword annotation of this. This is going to be annotate with int, literal annotation. There we go. A reference is just that plus the path info. And those haven't changed. Addition is indeed those. I think I'm gonna align vertically just because they are so similar that the structure will be more obvious. This is, well, actually, I'm just gonna do it as there we go. Because for all of those, this is, I have two things, E1, E2, which are left-hand side, right-hand side. I put the thing between parentheses because that way it's the only way to guarantee that the precedence is kept properly, since that precedence is lost when we have built the tree. Plus the operator, plus recursively going for the right-hand side. So that one, that series of things, they're all the same. I feel okay. It's a bit weird when the rest of the stuff is not aligned vertically. Oh, that's fine, I think. Okay, and now that's almost everything. We're missing... why do I have them different? I think at this point there's no reason for them to be different. Oh, they are different. They are different because how the arguments are given depends on where they show up. So I have to go back and be careful with this. This is going to be a path. Everything in the expression is going to be a path, but all of the others are going to be type. This is a type. Let me just check something actually quickly. If I have a type alias, I guess I could check the parser instead. Let me check the parser. I just want to check that if I have type arguments in a type alias, Where are you? Type alias. Use alias. There we go. Here I have a type expression, and those are not the same as a path expression. Type expression. Where are you? You're there. Yep, the generic arguments are there, and the path expression doesn't have. Yeah, the path expression is different. Path expression has the double colon before. Okay. So indeed, I need to change. This is a type. That's a pretty type. That's a type. Oops. That's a typo. And that is a type as well. Because a test I have is that when I generate an arbitrary AST, that I can pretty print it and then pass it back, which is not perfect as a test because it doesn't just test the parser, it also tests the pretty printer, which, you know, is not the thing that the compiler really cares about, but it's still not a bad test to have. Pretty type, where do I have other path thing? This will be a pretty type as well. This is for let, that's a type. Here, that's a path expression, that's a path. Pretty path there as well. Cast, however, cast is a type. And for a struct expression, that is a path. Okay. So pretty of a path, given a path info, which is an example again of like, if I had, for that thing I already didn't have a type class, because a path info will be printed differently based on where I'm printing it. So for this one, I had to have different functions rather than using an instance of the type class. So that's part of the logic why I'm rewriting this with functions rather than the type class. I'm generalizing this thing. So what is the difference here? Intersperse with this thing, list map pretty identifier. That seems good. Followed by. Aha, I see why. I see why pretty params was done with a function, and I see, okay. I've been too quick to remove some of the old code, despite the fact that in fact it was correct. And so pretty params requires, yeah, okay. Okay, so I just need to go over pretty params every place. And I have to give it what is the function to call for the individual parameters, which is just going to always be... No, it depends. In some places, it's going to be pretty identifier. In some places, it's going to be pretty type. And what the opening thing is, which will depend, which is going to be just a normal thing for most of the uses so far. So pretty params, here the function is going to be pretty identifier. And this is going to be... I guess I could introduce a new function for this rather than having to do this everywhere. Like maybe pretty params remains pretty params because it's going to be the same everywhere. And it's here that I use pretty params is almost always going to be the same thing, which is just going to be pretty params with, and here I give it this and pretty identifier. And this is also a pretty params with, pretty params with. In the case of this is both a pretty type, but different opening arguments, and pretty params with is this one. Okay, and I'm only left with pretty block, and pretty block is going to be, oh, I need two. Both of those will require having an annotate path. There we go. And the block will be a hang 2. Well, is that true? I guess it is. I guess it is. It's going to be a hang 2 of braces of... Well, of VSEP. I can rewrite this as... Those are separated by vertical, by new lines. And every line after the first one will be indented by 2. Oh, I have a place where I have... Yep, here I have this HSEP, VSEP. No, okay, this is fine. Yeah, here it's going to be... Let me think for a second. I think I'm going to do it with like a concat like this, so I can have a list in the middle here. And then at the end, I'll have another list here, and that way I'm just going to concatenate that. A bit inelegant, but it's going to work. This is going to be a map. I don't even need to do a do block. This is purely a map pretty of located and pretty statement of the block. Actually, this needs... no, okay. I'm not going to do the hang 2 here because this needs to be at the same distance as this. So this is going to be an indent 2 instead. Okay. And that should be everything. I'm going to have to add the GHC option to not get warnings for this. But hopefully this is enough to at least get the text pretty printing version of this, and then we'll do the HTML one for debugging purposes with syntax highlighting. Let's try to see if this compiles. It won't, of course, but you know. Wait, I thought... Oh. Is this one the one we've just done? Yes. So I'm going to remove the old one. Actually, I'm just going to do it here. Because this will only be re-exporting stuff from the other module, which means for now it's going to be empty. We might actually just remove it altogether. I don't think we need to keep this one. Okay. It's actually pretty printer with a lowercase p. Okay. Okay, I'm missing a few imports that used to be there. I'm tempted to just go look at the code on dev. Oops, main, what am I doing? Lib is what I want. Looking at the AST here, there we go. And that's what we had. Pretty printer run the text, okay. Lens, kind, non-empty, okay. And I can probably get rid of this. Ah. So here, likewise, we have things that are located within a view located. I can just write it as this. Okay. Pretty identifier. Yeah, I haven't done pretty identifier. That's a good point. Pretty identifier will be. I think it's enough to just get the raw identifier. That gives me a text. Raw identifier. I think that's enough. Oh, here I am missing $. Actually, I think I'm not gonna want to keep this annotation here. I think I want to keep the path annotation only for types and path in other places. I'm almost tempted actually to keep. No, I think I'm gonna keep it that way. Okay. Like maybe path annotation are not really required. That's fine. Okay, so what do we have? Ah, identifier is not is just returning the text. I thought there was, but it's not implicit, I assume. I need to do something to make a text out of this. Oh, I guess I can look at how. Because there is here in identifier. Yeah, I guess. Although I'm tempted to do a thing, I'm tempted to remove this and to not have any mention of the pretty printer outside of the pretty printing thing. To really isolate that library to this part of the code. But I suppose I then get the text and then do pretty on it, and there must be an instance of pretty for text since I was using a new type deriving before. Of course, I touched the identifier, so I have to recompile the entire world now. That was to be expected. Okay. What is wrong now? Ah, all of those I think take are with a location. Um, wait, no, I'm doing the located here, so that's not the problem. Okay, so there's another problem then down the line. Pre-const. Where do I have you? You're here. Ah, of course, no. Let's see. What else is wrong? Path name no longer exists. It's path body. I'm not sure what's wrong with the const one. So for now, it is a matter of with location thing. I'm not sure what that is. Okay, let's continue. This is the wrong type for the annotation. Okay, let's fix that. Oh, why do I have the prompt twice here? There you go. Huh. Oh, is it a case where... Ah, okay. So no, I'm gonna have to specify... That's the problem. I see, I see. I was hoping that I wouldn't have to specify the types of all of those functions because they are fairly obvious from context. They are, in fact, not obvious from context. Because this is taking as an argument what the compiler figures out that this is a common expression which is used across different phases of the compiler. However, what is the type of the sub expressions depends on what phase of the compiler we're in. And the compiler cannot infer that which phase we are in purely based on the types, on the constructor there. So we are going to have to be explicit and say that this is given an expression, since I have imported the module that does the re-exports, is going to be whatever we have. What is the type of those things? A document annotated. So this is a document, as far as the pretty printer is concerned, with an annotation, which is our custom type. So we are going to have to add... Oh, god damn it. I've lost my layout. One sec. And of course, since I don't have the feed, I don't know how big this is supposed to be. It's going to be like this for this evening, and I'll fix it tomorrow. And this is the roadmap. There we go. Good enough for today. So, I'm kind of tempted to do a thing, which is to generate this automatically for most of them. So I will find at the beginning of a line a pretty followed by a bunch of characters. And I'm going to replace this with Almost. Let's try it again. But let's also remember to add the pretty here. There we go. It's not gonna be perfect. Because such like pretty path info here. Path info here as well. Params doesn't exist. This is gonna be a list of identifier. Params with doesn't exist either. This is gonna be very different. This is gonna be given a function from path info to doc annotation and some text. Well, I guess some document actually. And some list of not necessarily path info actually. There we go. However, everything else, this is indeed expression to annotation. A bunch of those are info. And I might not have aliases for all of them, so I might need to... Return doesn't exist in this case. This is purely a maybe with location expression. Okay. Function info. Const info. Struct info. Enum info. And type alias info. And we are done. And that's indeed a with location expression. Still an issue here in the const expression. Is it because it's not actually located? What is in a const info? No, it is an expression type. Oh, expected with location thing. Actual expression type. Well, yes, but expression type past is. Expression type past is a with location expression. That's the whole point. That's the same thing. Oh, is it a problem of... No, I do have an expression here. Do I need flat map? That's a good question. I think it's not a problem of needing flat map. I think... Oh, wait, is it just that pretty... That's the... Okay, so I have... Here is an inconsistency. Here I'm saying that I need the thing with the location. And here I'm extracting the thing within the location. So I have an inconsistency here for sure. The thing is, do I want to... Yeah, I think since it's easier here to have go remove the location information, I might change this. So every pretty expression here will not remove the location information and let the other function do it. So here this is just E. Unless... Nah, I think it's fine to do it this way. So likewise, this is just if expression. I could make the case that like statements should be the same as well, but there's so few places where I actually go over statements. There's only one place that I don't think it's really that important to do it. So here, likewise, that's just a for range expression. Okay. Let's see. Okay. Path body is ambiguous. Is it because it's not named path body and I'm wrong again about the name I have chosen for this thing? Possibly. Maybe it's path base? It is path base indeed. For some reason, I never know which one I've chosen, and every time I type one, I like I get it right 50% of the time. Maybe that means that name is not good. I should change it. Oh yes, okay. So here I need to do this, this, and do a vsep again. And here map pretty is wrong. This is pretty identifier. And hopefully with this we're done. Let's see. Almost pretty identifier. Okay. Perfect. Okay, perfect. Let's just do a test. If I go back to my main, my actual main, there we go. Here I have, I'm just gonna go back here. It's gonna be more readable. Here I have the past AST. Let's do a print of so let's import there we go. And let's have a look at, once this compiles, let's have a look at what we're pretty printing and let's see. Data text doesn't have, I'm fairly certain text has something like this, but maybe it is text IO. Oh, it's, yeah, there we go. Just gonna do it qualified as T instead. Wait. Read file, that's the one. And here, lift IO of this. And if this works, we can look at the file that we had in input and see that whether the printy printer looks okay. A lot of it is commented out, so there's probably not gonna be much. We print. Oh, I should probably use like more new lines, but we print B1. Oh, it has a space that we probably want to remove. Okay. But otherwise, that looks pretty decent. So let's fix this. There's a bunch of spaces that are really not required. So functions are where we have Yes, okay. So I think I'm not gonna use the H step here. I'm gonna do a bunch of explicitly chaining things. This is with a space. This is without. This is without. This is with a space because... actually, I don't know. No, it is without here. And we do this thing. And then we put a space there. And here, if we have something, we will put a space there. Manually. Okay. If we try this, that looks a bit better. So now let's try, for comparison, a function foo that doesn't have a type here, and let's try to see if nesting works properly. If true, while false, let x equals 0, y equals a plus b. It doesn't matter if this is correct, it will fail to compile, but as far as printing things, this should work just fine. And this is going to be a struct expression with bar equals a string literal. There we go. Let's try this. This will, of course, not compile. All of this is wrong. I have something wrong where... Oh, yes, this is the wrong syntax for this. A struct expression uses the colon, not the equal sign. Okay. This is pretty printed as function foo that does if true while false with the thing on the same line. I have some space after the let here that's not required. Okay. Ooh, and here... I think the left-hand side of an assignment doesn't require... The left-hand side of an assignment and the right-hand side of an assignment do not require a require parentheses, so we can probably simplify them. And I think a path expression does not require parentheses either. Oh, but I can't know that for certain. Yeah, okay. Some amount of parentheses is unavoidable, which is fine. And here we have a function call, but here, okay, so there's a few things of spaces that we can improve. We can improve after a let. Where are you? Let, there we go. Those are all separated by spaces, I suppose. That makes sense. Yes, here I put a space before this thing and then another one after, even if this ends up being empty. I see, I see. Okay, so maybe I should do the same thing of being very explicit. This is with a space. This is with a space, and this... Well, no, this is without and this is with, and if... Yep, that's better. And then this is with the space, and this is without. Okay. And now for assignments, I'm going to do this here so it's more readable. Right. Oh, yes. Here, there's a few places where I don't need parentheses. Like, I don't think... Yeah, I can't always know if something requires parentheses or not. So I don't want to spend too much time doing complicated logic to try to detect when we don't need it. So I think it's just easier to always put it. Like plus and all the others just parenthesize everything. Which means we will parenthesize leaves, it's fine. However, for the assignments will always be... Well, again, theoretically assignments will always be correct, but that's assuming that the programs that we are printing were correct in the first place, which they might not be. Someone might try 3 plus 4 equals y, and if we want it to be parsed correctly, then the parentheses are required. So I think we don't have a choice but to keep that, which is a bit ugly, but a bit ugly. Correct is better than beautiful in this case. But with this, we should have fixed some of the weird spacing. Yeah, that looks better. Now we just have a bunch of parentheses in a bunch of places and then technically not required. Oh, the last we need to fix is struct expression. Yep, the path here is not separated with a space. Okay, and now we have fixed the pretty printer, which means we should be able to try. I'm going to remove it from the main. There's no need to keep it there. There's one thing we can do immediately, which is to go fix the tests. Because I haven't tried to run them in a long time and they're going to be very broken. Let's see. Ah, we're recompiling everything. While we do that, I'm going to go have a look at the tests, the actual ones. And let's see. I think the passes were in the integration test. There we go. Yeah, I have this pretty print function here that is expected to exist, and it will need to be imported from. There we go. Oops, I probably shouldn't have interrupted the compilation. Oh well. It's fine. Wait, why is it rebuilding every... Oh, it's the thing of like, if I do a stack build and stack test, it changes the configuration. Using stack test switches to the test configuration, so it has to rebuild everything in test mode, and build is without it. So if I do stack build and stack test, I'm going to have to rebuild everything all the time. Let's not do that. Okay. Module. Which... Oh, that is a very old helper file. That is not really. Do I still need this? I think so. This is no longer correct. Analysis has changed. It's going to require 1, 2, 3, 4 hash maps. Okay, that's still correct. Name parse module. So no, okay, that's correct. Perfect. Parse module is no longer something that is in scope. That's because this is coming from stages parsing. And I'm also going to need stages analysis. Okay. Yes, this is no longer the way this works. Analyze module now returns the interface directly, but needs to be in a monad diagnosis, which is no longer something that we have. So test compiler will be rewritten to be monad error string is wrong. So I suppose it is a monad diagnosis instead, which we will need to be aware of by importing the internal stuff. This is diagnosis. That means how this throw error will not work anymore. Oh, what kind of parse error do I use? Does my parser... I think my parser doesn't use the monad diagnosis yet. That's something we'll need to fix at some point as well. I think at the moment, parsing, yeah, just gives me either a parse error, and I think a parse error at the moment is a string. Yep, that is a string. We'll probably want to change that. For now, how do I want to handle this? Perhaps I want to do that this is a monad error string, so I can do both. So this becomes a diagnosis T of that. So if I run the diagnosis T first, well, no, okay, let's not do that. Let's keep it the way it was. And whenever I do the analysis, I will instead I will instead do a run diagnosis T of this and assume that the base case is identity. Yeah, I suppose that's a conflict. Yeah, that should work. Oh, and I guess I could instead, rather than doing this identity stuff, I could perhaps just do that and say that I am in a monad on top of my current stuff. There we go. Those tests are very, very old and not great, but they existed, which is better than nothing. Stages, I need the simplification stage. Okay. That's the test of the simplification phase. I'm going to need the AST validated, which is what things operate on. And I will need stages simplification. Now, I will need to change this. It's no longer definition resolved or anything like this. Expressions is not something that exists. This is typed expression now. That's also not something that works because const expression have something different. They have const expression, not expression. But the thing is, I don't do simplification on const expressions because they are always simplified, so I can just remove this. Okay. Okay, so list files, take the base name. I still haven't decided what the extension logic like system will be for this language. I kind of want to use the same thing as something similar to Haskell and other languages. So I will want to have an extension for interface files that contain everything that is the result of the analysis phase that is used to compile other modules. And I will want, so I would probably want something like it's HI for Haskell, the Haskell interface. I will probably want to use something in O for the compilation object, just like C++, like .o is the exported stuff. So PI, PO for interface and object would make sense. But then there is what is the source then, and PS would make sense, except Emacs parses that as PostScript, and that's not great. I'll have to decide what is the convention for this language. But yeah, working theory, PS, PI, PO would be what I think I'm gonna go with. Is there anything else I need to change in this particular test? We'll see. That's yes, okay. That is indeed a problem. I'm doing this on a definition, but definitions in the validated phase no longer contain the actual code, the actual expressions. So I will need to take a symbol instead, which is a function info, which, so this becomes that. And here, when I do the expressions, okay. So here I will want not the definitions but the symbols. Okay. And let's check whether this works. So this test is basically, okay, we have a simplification phase when we're done validating the AST that removes unnecessary, like it's a very basic AST rewrite for optimization reasons, but not the full optimization phase yet. This test checks that the thing worked the way we expect. This is going to be actually doing this. Come on. Ah, yes, of course. In the case, okay, I don't have. Range expressions are not. So this needs to be this. There's a separate type for range expressions in my new validated thing post refactor. Oh, I suppose I could. Yeah, okay. So from range expression, there we go. And from range expression is going to be a case, oops, of one of these two things. There we go. Because a for, after we have validated everything, a for loop, we know that the expression must be a range expression. So we have a dedicated type to represent that. That is. Why are you confused by this? Oh, because this is expecting this to be without a location, which is not true. There is a location there as well. Not there yet. Not done yet. What are you unhappy about? Oh, I am gonna need to in fact import common here, I think, to have access to those constructors that are shared and are not part of the interface. That's a bit annoying. This could be, yeah. Mm, 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 mm. The re-export not being perfect from common is a bit annoying. Maybe we could try to fix that later, but that's not super urgent. Okay, so maybe I will instead import specifically what I need. I need let expression. That might be it. And fun body. Okay, and that might be the end of it for this file. So we're one step closer to the tests compiling, which is nice. Okay, so here we're gonna need the same thing of, we are gonna need the representation ist past. What are you complaining about now? Ambiguous reference. Oh, this one is not ambiguous. This one is the one. So, yeah, okay. Wait. Do I have a different let info invalidated? Is that the problem? I do. That's what's happening. This is not a let expression. This is a let value in this context. So this goes away. That's why. That's what was happening. Okay. And now I just have to fix a few more things. Test definitions. Let's call test symbols now. Likewise here. I suppose, yeah, there's no longer any symbols there, so any location information there, so we remove this. No instance for equality typed expression. Yes, that is something I have been wanting to avoid. There is no equality on expressions, which is a tiny bit annoying, I suppose. Can I? What's the cost? What does it imply? To put equality on the expression type here. Will this break everything? This requires equality on so many things. I don't know if I want to do that. So maybe I can cheat here. I can cheat. And I can say, if the goal is to prove equality of the two things, maybe if they are the same, their debug representations will be the same. And therefore, since I'm only using the debug implementation of the default implementation of show everywhere, I might be able to say that I compare them using show. I turn them into string, which is going to be their like Haskell representation string, and then I compare that, which is the fact that the simplification phase is not needed here is bad for the simplification test, unless it's because okay, no, it's because here I'm doing the simplify phase manually. I don't need to actually call it here. That's why. I'm using the one defined in this particular helper here. If I go back here and I go to simplification, the structure here is a bit more readable. I run a test compiler with the fake file name, and I pass a simplified version and I run the analysis. And for the source that I compare against, I do the analysis and then I simplify. And then I check that their symbols are the same. Okay. And now we have to fix the arbitrary code. So it's going to be here. This is all going to be the arbitrary past, I believe. Like I'm generating an arbitrary past version. I might want to actually be explicit. And this is an arbitrary past definition. A past type alias info. A past enum info. I want to match this and then this, this, and replace it by past underscore one, backslash one. Go. Let's see. Will this work? Well, okay. I want to believe. Okay. We're not that far. So this is past module, so I'm gonna need... Is it in the compile thing? It's not. This is the actual one. So I'm gonna need stages, parsing. There we go. Ooh. That's okay. So most tests are working. The simplification tests are working, which is good. The basic unit test for encoding of weird ASCII values and of kanji literals is working. And here, oh, that's because I have a golden test file that's different. Round trip is bad because those are randomly generated, so that's bad. For golden tests, I am not too worried. in the sense of like, yes, we've changed the pretty printer, so it makes sense that things would be slightly different. For instance, if I look at integration parsing basic.golden, oh yeah, there's a bunch of spaces here that should probably not be there. And the golden one has a bunch of spacing here that we probably don't want. Yeah, I think I will want to just, in this case, I'm going to remove the basic golden, rerun the test, which means it's going to succeed, and we can have a look at the diff. Oh, it does put spaces there as well. That's unpleasant. What's the difference? Wait, there's no difference? Why is there no difference? What does that mean? So the pretty printer... So the golden test was failing, but I regenerate the file, and it's the same? Huh. Oh, wait. Is it a thing where the golden file... Yeah, of course, the golden file is not committed to the repo because I want the tests in CI to always run, so I need to have a look at how things were. So that's why there's no git diff. It's because so what's the difference? Aha, spaces here in the commas. That makes sense. The new version puts things on a new line for... Oh, but this thing for structs is wrong. Okay, I need to fix this. That is wrong, okay? Okay, so it is some basic changes, otherwise everything looks more or less correct. But that might be why the pretty printer changes might be why things are broken for the round trip test. So, inform with this. Let's look at the golden file. Oh, the scratch one, this one. And let's go fix our pretty printer. And the things that are obvious to me first would be the import statements that have spaces that should not be there. So let's do the thing again where I remove the hsep hcat thing, and instead I'm going to be very explicit. This requires a space. Then this does not. With spaces there, however. Okay, and no space before the semicolon. There we go. That's better. For a const definition, we're going to want to do the same thing again. Because here, yeah, that's ugly. Let's remove that. And instead, this has a space. This does not. This has a space. This has one as well. And there we go. Okay. Functions are a lot better than they used to be, which is good. Structs are completely broken because I've tried to do something smart and I was wrong. Yeah, structs are very broken, so let's fix that. This is this plus a space, no space for the parameters, and no space for the open bracket. No hang 2, that's wrong. However, here, an indent 2 of this thing, where instead of doing this, I have no space at first, a space after this for the type, and then a comma. There we go. So this should still be broken for the golden test, but hopefully the round trip one works now. The round trip ones work, which is nice. And now this should be broken because the syntax is slightly different. We have spaces here in the use that we didn't have to used to have before. We no longer have the weird space here or here. Those have been fixed. We no longer have a space before the type of the constant. We have spaces in the enum. Structs have their field on a new line, but now the field is correct. Oh, I suppose I could put a space there, actually. Yeah, I suppose it would look better with... Again, this evening is the less important work. That's the right file. I want to go back to the struct. Yeah, I think here I might want to put a space. I think it will look better. Oh, but I want to check that there isn't space after the closing bracket there. Which I think there is, and there shouldn't be. And this is probably an artifact of how I separate blocks of things. Yeah, the spaces are still there. Why are the spaces there? So when I do a block, if I look at an if, let's see. Maybe a while. That's going to be easier to see. Oh, no, this might be... Yes, that's exactly what it is. It's because of this thing here. I have a space because I have an HSEP, and therefore, even if there's nothing here, this gets... Okay, yeah, I see. What's the best way to do this? I suppose I could do something like this, where rather than having an entry no matter what, I do a plus plus here, or this even. And this becomes... I'm just going to put it on a new line just for readability. It becomes this list. And this list. And now there's no empty entry in the case of a nothing, which means we should no longer have the weird spaces at the end. Oh, yes, of course. There we go. So the golden test should still be broken. But the round trip should still work. Oh, sorry, I hadn't seen your message. Pro space between... I think we ended up doing it, right? The struct definition... Yeah, we ended up doing it. Okay. So here, this should still be wrong, but now... Okay, there is no longer a weird space at the end. So I think I'm just going to move the old gold file, run this, check that the diff is okay. Wait, I want... That's not fantastic. Why are you not showing me the diffs here? This is not the same. Huh. There must be a way to... Like, no space change is not on by default. Oh, do I have an alias to diff? I don't. Huh. Because that diff is just flat out wrong. Oh, is it because it's not taking... Wait, was it dash A? To tray... Yes. Is it because it does not consider those files to be text? No. Why is diff not showing me a proper diff? That's fascinating. If I do a regular diff? Yeah, now it does. Oh, okay. It shows those lines are different, but okay, so it's not saying this one is the same. Okay, so it's just showing the line is different. That's fine. Is there a way for it to show it like difference per line rather than just like the line is not the same? Ah, so not the regular diff, but some other diff highlight. What is that? Okay. Okay, so no. I'll have to check. I'll have to try and find a better program for this. Oh wait, do I have color diff actually? I have color diff. Is color diff able to do this, or is it just an alias? Okay. It just seems to be fascinating. Okay. Okay, I'll have to install a better diff for next time because this was confusing. But yeah, okay, and it doesn't show the white space. That's annoying. Because yeah, all the files are different completely now. This line is the same, I suppose. But the new one is definitely better. So we keep the new one. Wait. Okay, the lines have been added here, but... Aha. No, that's the old one. That's the new one. That's better. Yeah. I think it's good enough. So we have fixed the tests by putting the pretty printer for a past module. The annotations are completely unused, but I'm very tempted to try this thing of making something that outputs not raw text, but HTML instead, and making something that generates like a basic page thing. Something like... So I would rename this perhaps to like two... Pretty print is a good name. Pretty print text and pretty print HTML or something. And we're gonna need two dependencies here. How are they called again? There is a thing, I was looking at it the other day. There's a module for, if I look at Pretty Printer, dash lucid, perfect. That's what I want. Oops, no. There we go. So I will want, oh, that gives me a reference for where this is supposed to be when the camera is on. It's supposed to be here. Good enough. So I will want to add Pretty Printer Lucid, which has a rendering function that, given a simple doc tree with annotations that are just modifications to an HTML document, will give me an actual HTML thing, which is coming from Lucid. And I will need, as a result, to also have Lucid in my dependencies. Okay, so what will this look like? This is going to be pretty module as well. Actually, I'm going to change something here. I'm going to change, if I go back to Pretty Printer, I don't want the default options. I don't care about... do I care about line length? And I think I don't. Which means I could instead do a layout options. And options will be a layout options with a page width, which will be unbounded. There we go. And here we're going to do a pretty module, which is going to give us a document annotated with our kind of annotation type. Then we are going to have to do some kind of mapping on the thing. If I remember correctly, the document type is a functor over the kind of annotation. Sorry for the rapid scroll, I'm trying to find the thing. Yep, it is a functor and traversable and everything over the type of annotation, which means I can just translate every annotation into something that makes sense in the case of an HTML thing, and then use render HTML to get the HTML. Oh, but this is a simple doc tree, which is not the same thing as a document, which is a simple doc stream. Because the simple doc stream is the result of a layout thing, which means I need to convert that into a simple doc tree with tree form. Okay. So I do the layout smart with the options in the same way. Then I do a... Well, first I'll have to do... I'll have to do an fmap of HTML decoration, HTML annotation, I suppose, whatever that ends up being. And after that, it will be tree form. And after that, it will be render HTML. And I will obtain an HTML thing, which is this thing from Lucid. And then I can render that as text or anything that I want. I might not do it as part of this file. That will then decide what to do. We'll decide what to do with it later. So I will need Pretty Printer. What's the name of the module? It is lucid. Okay. And I will need import lucid as well. And I might decide to put that on a new line so that it fits 82 characters. That's fine. Now to decide, so an HTML annotation will be something that converts an annotation into a function from HTML to HTML. How do we decorate a node in the generated HTML thing? And this is going to be, I think, just a matter of putting a class and nothing more. And then we let the CSS handle what we want to do. And I think for now, at this point in the thing when we have zero semantic information because we have not passed anything, the best thing we can do is just like put a class on each thing and then let the CSS handle that. I think that's just class what I want. There's no class. There we go, with an underscore at the end, given some text, which is the name of the class. Okay, so, and that's an attribute, and an attribute is interesting. But I think an attribute can be used as a function because I think there's this term thing, which is, We'll see if that works. Aha. So maybe this is what I want. I want the with. Let's try. Let's see how that works. Because those are not their attributes. Okay. Oh, I suppose. Ah, I see. Okay, there's a problem there. My approach isn't gonna work. I was planning to just like, okay, then for this particular thing, we're just gonna apply the class, but that will not necessarily work in the sense that okay, so I will need to create, okay, I think I know what to do. I need to put a span there. And a span is a term arg result, and an attribute can be, okay, so this is going to be when I encounter an int literal annotation, the result will be a span with the class, and how do we call that? Syntax int literal or something like this. Character literal annotation string. I think we can use the same string literal for both. That's fine. Keyword will be syntax keyword. And path will be syntax path. Let's try that. Or perhaps if I want to make a file that contains both a parsed version and the rendering of, perhaps I should be very clear, this is for the parsed thing, okay? So hopefully with using the exact same thing of we're pretty printing this, since we are decorating a bunch of things with those annotations, it means whenever we encounter them in trying to transform that into HTML, we'll just like put a span with the proper class around them. Hopefully this works. We'll see. Now, I suppose we can do something like this, where we make another module that is purely for the export of an, oops, wrong one, of an HTML page, and we can use that to embed a bunch of documents. Something like that. What would that look like? We would probably want to use a file embed for the style sheet rather than writing it in pure Haskell code. I could use a templating thing, but I think this is starting to be extremely overkill for something that is not supposed to be. Like, do we want to do something like something that takes the body as an argument and returns the raw text? And that's going to be, we go to Lucid again. That's a Lucid render text, okay. And we will want to do something a bit smarter than this. I want to have a quick look at an example that's a bit more interesting. Like, do we want to do something as basic as doctype HTML? And the body, and that's about it, basically. I probably want the style as well, yeah. Probably something like that, then. Goddammit, I'm not used to this library at all, so I keep alt-tabbing back and forth. Sorry for the flashbang every time I do that. It's at the top. Yeah, there you go. Doctype HTML. And what do we do? We're gonna do a style thing to be defined, and then body with the body there, and that should be about it. Just for debugging purposes, that will be good enough. And I suppose here we will want to, the style is going to be term raw. Okay. I wonder if we could instead. I wonder if we could just like dump an actual like pure text thing rather than having to use the DSL for this. Just like embed this thing, please. I suppose it might be the case of. Oh, yeah, okay. Raw text is fine. Okay, perfect. So I should be able to use. I should be able to use raw text there. That means file embed should be fine. I do use this one, and I use it in the tests, I believe. So if I go back to the tests and I do have a look at locate, locate is a bunch of template Haskell magic, but that's not the one I want. List files, yeah. Do I do a file embed anywhere? I thought I did. Maybe I don't. It will be a byte string, that's fine. Path is given relative to the project root. Perfect. That's what we want. Data file embed. Okay. So this would be. I'm gonna need byte string. How do I convert a byte string into text? Actually, this is probably gonna be in text. And it's probably gonna be a from UTF-8 or something like this. Like an encoding thing. Yep, there we go. Yep, decode UTF-8 lenient is probably what I want. That's an embed file, and I need to remember the syntax exactly. It is embed file relative. And this is going to be the path to the file. And let's put it in this folder. Something like that. Okay. If we try this, so I'm gonna need to have some style CSS here. And this is the moment where I reveal that I have no idea how CSS works. Well, not no idea, but you know what I mean. That's not my area of specialty at all. I want to go back to the pretty printing just to have the name of the classes I've been using. There we go, just to have some basic stuff. I think it's dot for a class. What would I want to have here? I will probably want to just like put some color and maybe put the keywords in bold or something and the path in italic or something like this. Something very basic. What's the most basic properties I can use? Text styling. Perfect. Fundamental text and font styling. Yep, that sounds good to me. Color. Perfect. So color is what I want. Can I choose? Font weight, okay. Okay, so font style, font weight, and color. Oh, I could underline things, but let's not go overboard just yet. So let's say that keywords will have their font weight set to bold. Let's say that int literals will have the color set to blue or something. String will have, I have no idea, red, orange. There we go. And for paths, do I want to do anything? Just maybe italic for now, just to have something. Okay, let's try that. So now I have the pretty printing thing gives me, I'm gonna actually change this that it's very clear that the only proper use case is pretty print text or pretty print HTML. Okay. So I'm gonna have to fix a few things where it's gonna be broken, but that's fine. If I go back to main and I import this one and I import export HTML, I think I can do is I have the file name. I can drop is it take base name? I think it's take base name. So take base name of the file name plus ast.html or something like this. And then we are gonna do, I'm gonna need to import Lucid in scope again. Let's do a text write file, which is the IO1. That takes a file path and a text. The file path is our debug file name. And the text is going to be the Lucid call. Well, actually, no, it's not going to be the Lucid call. I might not need Lucid at all, because I have the HTML thing that takes text, so it's just going to be render HTML. And I need to give it the body thing, and that's going to be pretty print HTML of the past AST. There's going to be a few things broken by this, but hopefully not too much. Aha, the problem is this printer Lucid is such a small library that Stackage doesn't have it. So back to stack YAML here, and let's add it to the extra dependencies. Wait. Yeah, and I don't need to add this. I can just say which version I need, and that should be enough. This Alex thing is probably no longer required. I had it since my patch was submitted to Alex, because the code as it was triggering the bug I was fixing. I can probably remove this now. And now we wait. How's everyone? While we wait for compilation to go through. Anyone here excited for the advent of code? And if yes, what languages are you planning to do it in? Aha. This requires... Oh, is it... Did I mistake? Oh, yes, okay, it's not capitalized in Lucid. It is HTML like this. Of course, as a result, it's wrong everywhere. That's to be expected. What else is wrong? Here indeed. Oh, I imported Lucid qualified. That's why. I don't need to do that. correct to assume that this render HTML is just not correct. It's probably going to be the same thing. The pretty printer Lucid probably doesn't capitalize HTML. It doesn't. That's why. I know that this thing of like not capitalizing initialism or acronyms is also the convention in Rust, but I really dislike it. It's the thing is doing it this way means that if you have it at the beginning of a word, then suddenly you have this, something like this, and it's more consistent if you have this and this. But it feels so wrong to me. I don't know. Tree form, now in scope. This is imported from there we go. So I wonder if I need this, or if there's something in Pretty Printer that gives me simple doc tree. No, okay. Tree form is the way to do this, so I will need to import this particular module. Okay. What next? Aha. This one is a lazy text, while the one I'm using everywhere else is the strict one. Is there something in Lucid to actually export some non-lazy text? There doesn't seem to be one, which means I'm going to need to. Sorry again, since this is an evening where I'm doing things where I'm less familiar with the libraries, I keep alt tabbing and I keep flashbanging you. Sorry about that. Is it too strict or from lazy is the thing. Too strict? No. From lazy? No. So it's just not in this module then. Ah, too strict in data text lazy. Okay. So I will import that, and I just have to do a too strict here at the end. We still have no idea if this way of embedding the CSS actually works, so we'll see. Byte string not used. Yes, because it's all text stuff. Okay. Write file is an IO thing, and that this scope in this temporary main thing, I'm not in IO, I'm on top of it, so I need to lift IO. Okay, the tests are broken because pretty print no longer exists. This is pretty print text, as opposed to the new pretty print HTML. Okay, tests should still be working because we haven't changed any of the actual behavior. Okay. And now, if I stack run PC on test for, I'm not in the right folder. Stack run PC on test for /main. Okay, I have errors. That's to be expected. Those are not like this is not the compiler like failing and erroring. This is the file contains error, and it contains. What does it contain? Role not found. Why? Yes, of course, because I've added earlier today a function foo here that's completely wrong. So we get a bunch of errors. We get that y, z, and bar are not found. The function bar doesn't exist. Oh, interesting. I was expecting this to also give me an error. Ah, maybe that's something we can fix. So instead of testing the thing I wanted to test, let me just have a quick look at this. This would be in the analysis. Specifically, this would be in the validation. And that would be in the validation of an expression. When we have a function call, so validate function call, in the case where we're calling an actual function and not... Oh, of course. This is not a validation error. That makes sense. That makes sense. This is not at this point. It fails because during the resolving phase, the name is not found. So I'm looking at the wrong part of the code. This would be during the resolution phase, when we try to map a name to everything. If I look at a function call in this phase, call expression, there we go. Yeah, here I don't do a try. And since I don't do a try, yeah, okay, I'm gonna have to do the thing. I'm gonna have to try to do this again. I'm gonna have to do it in a bunch of places, actually, come to think of it. Because what I want to do here is do a try of resolve path and resolved args will be a try nested of traverse try nested of resolve expression of the args, which gives me two maybe values. And now I want to ensure a lift A2 of the resolved path and the resolved args. The idea with the try being that we're going to try to resolve everything and fail if at some point something in this did not succeed, but we will collect all of the errors. And I will want to probably, yeah, here I do this mistake everywhere, so my resolving will fail very eagerly. If I redo this now, recompile with this one change, well, when it compiles, of course, this is going to be... Oh, if I do this, I need to do a get compose of this. There we go. Which means I might need to bring... No, it's already in scope. Perfect. Okay, this should be compiling. So now, if I run this again, I should also get, there we go, foo not found. So we say that the function bar is not found, but within the argument, we also identify that foo is not found. Okay, but that's not the thing we were trying to do here. I still want to go over my resolution phase anyway. We wanted to have a look at, did we export... We have a main ast.html. Let's see what it looks like. Where are you? Okay, that worked. We have the keywords in bold. We have the paths in italic. We have the... I don't know if the path in italic is actually good. That's actually pretty ugly. Maybe we don't want that. So maybe we don't bother with that at all. We just change the CSS. I'm pleasantly surprised by the fact that this worked on the first try. You can tell that graphic design is my passion by the choice of color and style. This is very ugly. Let's go back to the CSS. Where is it? There it is. I'm just going to remove that for now. But this worked first try. I'm happy with this. Now, the thing is, this is not what I meant to do. Well, I mean, what I meant to do. This is useful as a test, but that's not what I wanted to do in terms of debugging. Because now we have pretty printing of a past AST, which is nice for testing. And we have this debugging thing. We have this debugging thing where now we can look at the past AST. What I want to do now is do the same thing of doing a pretty print of the AST, but not on the past version, but on the validated version. Because we will have resolved everything, all the names will be annotated with like what they're actually referring to, and we can print something that's not supposed to be passed back, but that will contain a lot of debug information that will be more useful than looking at, you know, this kind of stuff in the terminal. Which again, not super urgent, but since this was an unplanned stream with camera off and not the usual setup, doing some tiny amount of work like this is not bad. Okay, so let's do this. Let's do something that renders the validated version of the AST instead. So we go back to the pretty printing press, I suppose, and we're going to do the same thing, but for the validated version. There's going to be a tiny bit more work to do here. Do we want to keep the text, the pretty printed text version of this? I don't think we do, because this version of the code is actually I guess we could. This version of the code is still technically parsable, so I guess we could keep it. No, let's keep it. Let's keep it. The only thing is, at this point, we no longer have the notion of a module. At this point, we only have the notion of a symbol, which is a function info, basically. I will also want to quickly do a thing. I don't like the way that... Yeah, I don't like the way this is. So I'm going to change this ever so slightly. Up, hard line here. And intersperse, which is going to break one of the tests, but that's fine. Hard line of this. There we go. This is going to break everything. So I'm just going to comment this out for now, just to get... it's fine. I'll test the other thing when we're done with this one. So we're going to keep the same thing. We're going to print a function info into text, which is going to be pretty function. Okay, because again, I don't want to use a type class for this. And we'll do pretty print HTML for the function info. Do I want to actually be specific? Nah, I think we can just import the module qualified if we need. And we are going to keep the same thing. However, we are probably going to want to have different kind of annotations because we will have more semantic information at this point. Okay, so let's open validated. And let's look at what a function info is. Where are you? Above here. A function info is a function type and a function body. Oh, that means we didn't even have a function name. That's interesting. Do I want to, therefore, instead... I might want to do that instead and take the name of the function as well, which is going to be the base name. Actually, the identifier should be enough. Although at that point, I might not have the identifier anymore. Maybe I will just want the base name. Okay, let's just do the base name and we'll fix this at some point. Base name here as well. So pretty function will take the base name, which means, haha, this is a blackbird. Okay. Pretty module, pretty import, those things do not exist at this stage anymore. Pretty definition doesn't exist anymore. Type alias, enum, struct, all of those go away. Const goes away. Pretty function is the only thing that we have, and we have the base name as an argument. We're gonna deconstruct the base name immediately because we only care about... Yeah, we don't care about the module name. So I guess we still want to have an annotation for keywords that hasn't changed. We still want to have pretty identifier that hasn't changed, but now this will be the base name, which is, so it's going to be this thing. Pretty params, which are going to be the function parameters that hasn't changed. However, where we get this is going to be, okay, we get the function type. Which is actually a function type info at this point in the life cycle of the compiler. And that's indeed fun type, perfect. So params, args, everything is the same. The only difference is here. Okay, pretty type is going to be indeed something that's going to take, this is going to be a concrete type every time. So pretty type remains, but it's going to have to be a different function. Okay, return is going to be pretty type as well. That remains the same. Pretty block, okay. So we want to also maintain a list of... So keyword annotation, yep, that makes sense. Path annotation no longer exists. Those still exist. We will want to... What will we want to have? what will we want to have? We'll probably want to have like a variable annotation with an identifier. Or maybe it's enough to say variable and reference annotation. Oh no, we could probably actually do something smart. We could probably use anchors and make name of variables clickable to go to their definition. We could probably do that. That would be pretty neat. That means, however, since a variable might be overloaded and shadowed, we cannot just use its name as an anchor, which means we are going to need to keep a state of unique ideas for each thing that we encounter that we might want to link it to. I suppose then we probably want to take a symbol cache then here to be able to render more than one function at the time so that we can link between functions within the same module. So this goes away then. This is going to be... I might make a useful function for this because we're going to be doing a traverse with key on this hash map to get the base name and, well, the name actually, but the base name is what we need, and the function info. Oh, this is going to be a bit of a problem, I suppose. So the thing's going to be a bit of a problem is since we are instantiating every function, every generic function differently, that means that if I only render a function name as its base name, I will have conflicts. So instead, it means I need to do a slightly different rendering to render with the full name and the mangled arguments in it. Which, in the worst case, since it doesn't have to be parsable, I mean, I kind of want it to be parsable, is the thing. I think it's okay if it's not. Okay, so that becomes... This becomes a flip run state with the basic state. Maybe actually I'm gonna... Yeah, I'm gonna actually introduce a monad for this. So our printing monad is gonna be a state monad where we are gonna keep variables. What are variables? It's gonna be, well, ideas. And ideas are gonna be a hash map from... Do I need a base name? Do I need a name? Or will I want instead, since something will be base names, something will be names, some things will be identifiers, do I want to serialize all of this and say whatever I end up choosing as the representation, which is going to be some text. Yeah, so it's going to be a hash map from text to text, basically. Yeah, I could introduce some type aliases, but that's fine. So we're going to be carrying a state like this. And then run printer will be a function that takes some printer of A and gives me the A, and run printer is going to be a flip eval state of an empty map because there is no variable at first. Okay. And I will probably add some more functions there. Oh, there is a problem there, however, which is that I will need, since I will need to know to how to refer what I need to refer to for a given thing, I will have to start by registering all of the functions in the first place so that I know how to link to them regardless of in what order I process them. Okay. So, how do I do this? Because this is going to be so this is going to be given a symbol cache, give me an annotated document, and this is going to be a run printer given our cache, where we're going to do a bunch of things in this particular state monad of ours. So first, we are going to... So for each... So for with key of the cache, I will do one action for each of the name and function info, I suppose. Although I don't actually need the function info, I only need the name. I only need to register that particular symbol in the scope. Let's do... Actually, I'm going to need to have more state than this. This is going to be our printer state. And a printer state is going to be the ideas in question, and this is going to be also some internal counter so that we can know what ID to assign to a thing we encounter. So our initial state is going to be a printer state with an empty hash map and a counter that's set at 0. Registering something will be given some text. Given some text, which is the name of something. Give me the corresponding text. I guess registering doesn't actually require returning the thing. Registering will be... I probably want to make lenses, but if I make lenses, then the order of declarations matters in the file, which would be very annoying. So maybe I put this at the bottom of the file so that the lenses don't actually interfere with the rest. Let's do that. Because I will want to make lenses of the printer state. Is it 1 or 2 quotes? I never remember. Let's look at the other monads we've been doing. I don't have lenses here. I thought I would have lenses here. I do, and it's 2 quotes. Perfect. Okay. So registering something will be, now that we have the lenses. Oh, god damn it. The fact that this function there... Okay, so this function there needs to be above. Because lenses, there's a very annoying thing with lenses. Well, not lenses specifically, template Haskell. By default, the order of declarations in a file in Haskell doesn't matter, which means I really like to have the thing where I have the API at the top. Those are the functions that are exported by my module. And then I have below that the implementation details, which tends to mean like it's a kind of like top-down approach where the top functions call the ones below, and like every function that is called is defined below. However, the second you use some template Haskell, well, the compiler has to care about the order of declarations, and everything that is below this, you cannot use something that's declared below it. So above this particular use of template Haskell, it's still fine. Below this, the order of declarations matters. And that's very, very annoying, which is why I'm putting this make lenses as low as I can. And the only thing I'm putting below is functions that actually make use of the lenses. And the rest of the code will. Oh, God damn it, the rest of the code cannot use those functions because they will not be in scope. That is annoying. That is extremely annoying. I guess it just means I have to reverse the entirety of the. Yeah, I have to reverse the entirety of the declarations in this file. Oh well, that's how it is. So, register. I guess I could just do it without lenses, but I like lenses for this. So, this is going to be I want to register something. That means I need to get the next ID. So, I get the counter value by doing a use of the PS counter. Then I increase the counter in my state by 1. And then I generate a unique ID is gonna be something like how do I want to name this? This is gonna be something that's gonna be the unique HTML ID of the thing. I guess it would probably be enough to just for it to just be like the base name plus a counter, basically. Is there some kind of printf in text? There's a builder thing. I think I actually depend on. I don't need to worry about this. This is fine. Wait, do I actually need. Do I actually need the ID thing? I do, just because say I have a notion of name in the whole compiler, and the whole point of name is that it uniquely identifies something within the program. So why do I need the ID? Variables will not necessarily be unique, and I want to point to the actual one. So no, I will need to do something like this. But I can probably just do whatever the name of the thing is, dash a unique ID, and that should be fine. And this is going to be a pack of show counter. Perfect. That's the unique ID of the thing. And now I can register by doing PS ideas. Within my state is going to be modified by doing an insert of for that base name, the unique ID is this. Okay? And this, the only tricky thing will be, and I will have to be careful with this, I will have to do scoping with the bracket again, because if I introduce a variable in a block, it will temporarily shadow the previous ones, but the state must be restored to the previous one afterwards. So I can probably just do a function for this immediately, which is going to be There's no need to handle errors there, which is convenient. So if I do nested, nested will take some action, and it's going to do mapping is going to be the result of doing a use of the PS ID. I will call the action, which gives me some result. Then I restore the mapping, but not the unique ID. So I do PS ideas is equal to the mapping, and I return the result. Okay. With all of that done, so this will be at the bottom of the file because of the lenses, frustratingly. I guess an option would be to put that in another file, but it feels a bit like this is self-contained enough. There's probably no need for that. So annotations will need to be above. I don't know yet what kind of annotations I will want. But I think I will want the text of the unique ID of the unique ID thing I'm referencing, so that I can make a link to it and I can make this clickable. Likewise for a reference. Although that being said, maybe I don't need to distinguish between reference or anything. Maybe this is just like a link to something. Unless I want to do some different syntax highlighting to indicate what is a reference, what is not. So maybe I'll keep it that way. Likewise, I'm going to have a enum annotation. I'm going to have a struct annotation. Type aliases will have been replaced at this point, so there isn't going to be type aliases that I'm going to link to. They're going to be replaced at that stage. What else will I want? Built-in type, and that's probably not going to have a link because there's nothing to link to. So that's a thing we're going to want to annotate as well. What else will we want to annotate? I guess function with the unique text, so I can click to the definition of a function. And that should be it. We'll see if we need anything else. So this is going to be wrong. We're going to have to redo it. But it will be something along those lines. I'm going to have to change the CSS afterwards. Okay, except it's going to be a bit different for some of... well, we'll get there when we get there. The API is going to be at the very bottom, which means everything else here gets moved here because of the declaration order thing, which is very annoying, but that's how it is. So let's do this main, even though for now we're gonna have to change everything afterwards. The main thing we're gonna want to do at first is we probably want to do some kind of function for like given. I'm gonna actually make that a class, I think. I'm gonna for now temporarily do that just so I see more scope. how do I get the unique name, the mangled name of something? If I ever encounter an identifier that's trivial, that is, just get the raw identifier of the thing. If I find a base name what do we do with it? What's base name again? It's a module name and identifier. Okay. So this is gonna be a text intersperse with dash of a list, which is gonna be to list. So if we have some kind of base name of to list of the name module and the name identifier at the end. And the name will be mangle the base name. And then what do we do here? I'm gonna want to do some kind of something like this to make it very clear what's happening. Because dash and underscore are valid. Yeah, it's gonna be fine. And this is gonna be then an intersperse of actually maybe something like this, intersperse of dash of mangle the name parameters followed by something like this, which should be unique. I mean, it should be. Actually, I don't need to bother with any of this, since anyway the unique ID will guarantee that, even because I'm worried about something like foo of int and character becomes, you know, foo and dash int dash character. But if there was that, this could be ambiguous if I had like bar here, for instance. So this becomes foo bar character, which could be the result also of foo of bar of character. So this would be ambiguous, but since I'm gonna register everything once. Oh wait, but if the mangled name is unique. No, since when I'm registering something, it doesn't matter if I have a collision, so it should be fine. So it doesn't matter. So having the dash is perfectly enough. Okay. So I don't need to put the dash at the end either. Okay. Which means I can probably rewrite this as there we go. Oh. This is going to be the same thing. It's going to be a map mangle here as well. There we go. Okay. With all of that, we have our annotations. So we can start with, for every top level function, I will want to register the mangled name. So that way, if any function calls to any other, I will have a unique ID for them regardless of in which order I process them. Then I will want to iterate over this again. But this time I want to keep the result. I will do a for with key of the name and the function info. And for each of them, well, in fact, I can probably just do a traverse with key pretty function of my cache, which gives me a monadic list of results. Well, a hash map of results, I suppose. And what do I want? I want the documents out of this. So I will want the values. I think there is in Pretty Printer a thing for interspersing thing. Intersperse. There isn't? Oh, I'm surprised. I thought there was. There isn't. Interesting. Well, I guess I can use a text. I can use a regular one here. I can use a regular one. This will be the result of doing a vertical separation of intersperse. Is it intersperse or intercalate? I never remember. Google. I want the one that's like, I have one value of type A and I have a list of A and I want a list of A. That's intersperse. Okay. And that's going to be, if it's not in the prelude, it's going to be in list, but that's fine. And I will want to put a hard line between the documents and then separate that with lines. Okay, perfect. And that's going to be the result. That's going to give us an action in the printer, and then we run printer and we get the resulting document. Okay, so that's how we prettify a symbol cache. So now the question is, how do we prettify a function? Well, it's going to be something a bit similar. So the function name will be, I suppose, if I want this to be parsable, I will need to mangle with things that are valid identifiers. And I guess I would like this to be parsable as much as possible. It doesn't make sense for it to be, but we can try. So that means we will have the keyword function. Oh, and I also need to do a do here because we're going to need to do some stuff recursively. At the end, we will have okay, so we will have the mangled name. In fact, this is going to be a name. I suppose I could just do that and use a view. So now I can do pretty identifier, and that's going to be, well, that's not even that. It's just going to be purely a text, which is this. Except I think I need to... How do I make a text pretty? I think there's some kind of like... Doc must have a from string thing. I guess just a regular pretty is probably what it is. So it's going to be pretty of the name. There is not going to be any parameters because I'm printing symbols, and symbols are the concrete versions. So the type parameters will be part of the mangled name. Yeah, I suppose I could be having this rendering could have the same function, given the way mangling is done, could have two different functions with the same rendered name, but the links will be working correctly, so it's fine. Okay, so for each, we're gonna have to do we're gonna have to do a bunch of monadic stuff. For the function arguments, I'll actually do this here so that I have access to it. Let's make this a bit more visible. Let's put validated here so that I see what I'm doing. The function argument will be I will want to render them as documents, which is going to be so the arguments are gonna be a traverse of pretty args plural, well, not arg singular, uncurry pretty arg. The function arguments, which will give me a document for each of them. The return type will also be something where I will want to do, so the return, well, the return type will be as well a, so pretty type. Oh, actually, this is going to be interesting. I will probably want to avoid putting something if it's unit there. So I think this will probably give me a maybe thing. So this is going to be the fun return, which I think, yep, is going to be a maybe. And then I will need the body. Which is going to be a... oh, I need to register the variables here. I need to register the variables so that clicking in them, well, the arguments, so that clicking them will point to the right thing. So first here, I need to traverse for so for each of the arguments, I'll get the arg name and the type I don't care about. And for each of them, I will need to register the mangled name, so that if anything points to a variable or a reference or something, I am able to link to them. Next, what time is it? Oh, it's late. Shit. I might not be able to finish this evening. Okay. Cutoff point in 45 minutes. I'll try to see how much progress I can make until then. Then I'll have to go through the body by doing a nested. Well, I don't need to do a nested in this case, it's fine. Just a traverse pretty statement. Although I guess I can just do a pretty block, and I can just use that of the fun body. And at the end, I can combine all of this together. I have the name. I enclose with separators the argument, which are the documents already. Although I guess no, I think that makes sense. Then here a fold map on the maybe of the return type. And then I have the block, which is going to be the body. And that is how we are going to render a function. Okay, so we're going to need a few things. We're going to need pretty arg, pretty type, and so let's start with pretty arg, which is going to take an identifier. Oh, do I use this to register then actually? Maybe I don't do this here and I do it in pretty arg. Maybe that makes more sense. Pretty arg, and I will take the identifier and I will take the function arg type, which is going to be the concrete one. And that's going to be giving me an annotated doc in my printer. So let's, oh, because I forgot to change the type, this is also giving me not a document, but a document in my printer. This is not, however. This was supposed to be a small stream to do some progress on the non-important things, but as usual, so what are we gonna do? We are gonna need to register the mangled version of the name. And we are going to want to do, we will want to get the type. In fact, maybe for a type, I don't need to, no, I need that to be monadic because I might need to look up a name if I want to link to it. So this is gonna be the arg, so the printed, the type document is gonna be a pretty type of the arg type. Here I have made the assumption that this would give me nothing if it's not a type that can be represented. For the argument, it will always be representable, so I'm going to say it's a pretty type. Do I want to do this? Do I want to like panic if this is wrong? Do I want to panic if this is wrong? I think so. Especially since this is debugging code. I think it's fine to just do like a absolutely horribly from just on this. Or maybe pretty type gives me something regardless. And it's here that I do a it's here that I do something like if a case fun return of unit type nothing, and otherwise just of pretty type. Okay. So now I have registered the argument name. I have rendered the type of the argument. The result will be the arg name is an identifier. How did we do that for? Oops, wrong one. I meant to do this. Go to past. How do we render an argument to a function in this? So that's just gonna be pretty identifier of the arg name. Oh yes, here I need to. This is annoying. I really dislike this type. This is case arg type of. I will just want to do a traverse of this at some point, but I can't do that yet because I haven't done that yet. By reference, inner type, and that's going to be it's going to be, oh, in fact, this should be this of pretty type of the inner type, and by value inner type will just be, actually I'm gonna do it this way to highlight the symmetry. Okay. And that's gonna be the type doc here. Okay, that's all for the arguments. So we're done with pretty arguments. We've done functions. We haven't done type yet. Maybe I should do that. So pretty of a type will be taking a concrete type and returning a printer of a doc. Actually, could I use the type name? No, I can't do that. I can't do that. Okay. Oh, but I can't link to structs in the unless. Yeah, I think I will want to also include the struct definition in things, which means, but that means I will need to do substitution. God, that's gonna be tricky. That's gonna be very tricky. Okay, but yes, ultimately I will want to do this, which means instead of pretty symbol cache, this is gonna be, well, I guess could be that still. But the whole thing is gonna be instead, where's the pretty print function? Is at the bottom there? Yeah. This is gonna be taking an interface. So I can also print the type definition of the types. That way I can see what they've been resolved to, I guess. Okay, but this is so much more work. I'm tempted to stop this evening and go back to it when I do a proper stream, which will probably be tomorrow evening after doing the Advent of Code, because there's still so much to go through. Some of it will go fast, like statements are not going to be too complicated. Like I'm going to reuse some of the structure, but there's so much work to do to actually properly print all the things. But the goal will be basically we'll be able to have a printed version of the code after being resolved. And the upside of the code being printed after being resolved is we will have annotations. I can click like, oh, this X, I can click and it brings me to this X here. Like I'll be able to do some fun stuff like this, which will make, again, debugging what's happening a lot easier. Okay, well, since there's just so much more work and it's getting late, I'm gonna stop here for the evening. Thank you everyone for tuning in. It was a slightly unusual and unplanned stream. And I'll see you all tomorrow for the Advent of Code and perhaps for more work on this debugging stuff. Have a good night, everyone.